Hi, my name is Don Bergh, and I've been asked to speak about how to test reproducibility of empirical research in our management journals. And first of all, before I get started, I want to convey my appreciation to Mo and Gwen for asking me to give this talk. And I hope that they find this fits well into the workshop, and I hope that all viewers find this useful in interpreting reproducibility and ultimately the replicability of management research. Today I'm going to be going through a variety of tests and applications, and I hope that all of you learn from this presentation and find this material as interesting as I do. Let me begin with a question, and of course, given the purpose of today's presentation is to introduce us to reproducibility, the question of this will obviously be yes. But nonetheless, I want you to think about this question anyway. And this, how would you know if a study's reported findings are accurate and replicable without conducting an exact and full-scale replication? Just at the face of it, as you read an article, as you try to understand that article, how would you know if its reporting findings are really accurate without redoing the study itself? I'll be returning to this question at the end of the presentation today and giving you what I hope is a satisfactory answer to this question. My agenda today, after I introduce the topic and explain its relevance and its importance, is to show you the tests that we have available to us for examining reproducibility. I'll give you an application with a retracted article as well as an overview of a study that I've done. I'll talk about some implications for replication research and also get into some recommendations for moving forward as well, both for journal editors as well as reviewers and authors too. Now, most of today's presentation draws from a series of studies that I've published with my co-authors Herman Aguinas, Barton Sharp, Lily Lee Ming. I'll mention those studies as I go along, and if you want to follow up with them, please contact me and I'll be happy to give you the specifics for those. To begin with, it's important to recognize that all published research exists within a condition of information asymmetry. In other words, if we go back to the economists' work on this beginning really in the 70s, we know there's a condition where authors and readers don't have complete information of one another. More formally, we refer to this as when one party to a transaction has more or better information than another. Morris Stiglitz, who won a Nobel Prize for information asymmetry work, stated, when different people know different things. So quite simply, authors know more about their research and what they're publishing than the readers, the editors, the reviewers of that work. So it's important from the outset to understand that whenever we read an article, we're reading a finished version of that article, not so much a cherry-picked version of it, but certainly a finished version that meets whatever those authors' objectives are. Now, we generally assume that all numbers and all conclusions are correct when we read an article. However, research has shown us that peer review process, particularly the reviewers in this, often miss even obvious methodological mistakes. It seems that reviewers may focus more on the contributions, more on the sexiness of the topic, more on what they believe is intriguing about the arguments of the article, rather than dig into the numbers themselves. And we've had some studies of reviewers where people have introduced obvious, massively important and clear methodological errors that most reviewers have missed. And that raises a concern for us when we consider this notion of information asymmetry. That if that condition exists, it may lead us as readers to not even knowing if simple mistakes in methodology, findings, and reporting exist, or if indeed there may be misconduct by authors that have chosen to take advantage of that limited information. Now, we're recognizing these problems, and reviewers and editors have been calling for more replications of research, special issues devoted to replication, as well as special issues devoted to testing the reproducibility and accuracy of findings. The idea behind this increased transparency is that editors will demand and require greater disclosure of key statistics and methodological decisions in articles. In addition to that, some journals are adding an additional step in the overall review process to include having an expert examine methodological findings as well as output. Another solution to this, though, would be testing the reproducibility of the reported data themselves. Those previous solutions, while helpful by providing more information and more insights, don't really get us at the exact data themselves. And in many ways, those reproducibility difficulties aren't examined or considered with them, if indeed they may exist. So what I want to talk about today is reproducibility, and that's obtaining the same results when reanalyzing the same data. What this means is to confirm or verify reported findings. And I'm going to suggest it as a preliminary step in the replication process, and more generally as a monitoring device for reducing information asymmetry within publications and the publication review process. Now, it's important before we get started, though, to understand how reproducibility differs from replicability. Replication is assessing the generalizability of prior studies to new or different contexts, or to examine the robustness of prior studies to different empirical approaches, methods, measures, and models. As you can see, the citation from the SMJ editors here I mentioned recently. Another set of SMJ editors mentioned that reproducibility differs from replicability from the context of replicability provides additional evidence, again, taken from different study contexts. And the purpose of this is not to overturn prior studies, but to give us additional information about them. Now, reproducibility, more specifically, allows us to assess the congruence or the equivalence of statistical findings in the data upon which they are based. Now, that might sound pretty difficult because it implies reanalyzing original data sets and then comparing the reproduced findings with those initially reported. Such a process would seem to require either having the original data from a focal article or independently redoing the study. And that would seem onerous, and I think many people probably would see it from that light. However, there are 3 tests that we can use that get around that step completely. These tests are basically substitutes for having to collect new data or having to have access to the original data. These tests include a matrix, which I'm going to talk about shortly, calculating significance values, as well as conducting simulations. I'm not going to discuss those simulations here because another presentation at this workshop will do a far better job of that than me. So I'll just refer to it a little bit later on. For more on these tests, you can see my article in Accounting Management of Learning and Education that appeared earlier last year, 2017. First of all, this matrix approach is an alternative that many may not be familiar with. Those of us that were trained in statistics back in the day often had to use this approach, so I may be more familiar with those that have had their training back in the 1980s and before. But in essence, what this means is we take the means, standard deviations, and correlations among study variables. We take those from a focal study and we arrange them into a matrix, typical data matrix that we see as Table 1 in many empirical articles. We then can use these statistics to recreate a data set that is statistically equivalent to the original. And any subsequent analyses will be identical using that matrix relative to the raw data itself. That allows us, using this matrix, to rerun the models that we see in a focal study, then compare the findings. Reproducibility would occur when the signs, the magnitudes, the significance levels of the parameter coefficients, and indeed the parameter coefficients too, in the retested models are identical to those in the original. So what we do then is we use this data matrix and we run it through our conventional statistical packages, and most will do this, such as SPSS, SAS, R, among others. So when you learn about those packages in detail, you learn that they don't always and aren't exclusively limited to analyzing raw data. They also have a matrix read format that allows you to read a matrix in. And again, that allows us to test the matrix data just the same as we would the original data. Now, I have a quote here that this matrix approach allows you to perform analyses from these summary statistics, these correlations / covariances and means. When these summary statistics are all that you have, and what the program does, it extracts those statistics and then allows you to rerun the models. And I put in bold space here, the results from the analysis, particular regression, based on those are the same as those based on the raw data. So what we do is once we have the matrix and we have it entered into the computer, or we designate a program for the computer to access, we can use all variety of analytical techniques to work with the matrix, such as analysis of variance or multiple analysis of variance, ordinary least squares regression, factor analysis, structural equations modeling, cluster, discriminant, and so on. So a wide variety of our more popular statistical tests can be retested using this matrix approach. And again, simply what we do is we would just rerun the models of the focal article using the data matrix and then compare the results and see how close they come up. The advantages of this approach and disadvantages of this approach are important to know. First of all, it's easy and accessible and doesn't require raw data. You can find an article, find its correlation matrix, get its mean standard deviations, enter that into the program, and presto, you're ready to go. Major statistical packages have this, most of them do, and allows you to examine whether there's any discrepancies in the coefficients or the parameter statistics that exist. A couple of disadvantages, one I mentioned here, is we need descriptive statistics, those mean standard deviations and correlations for all the study variables. And that becomes problematic because many authors don't report the second level variables, such as interactions or transform variables, squared terms, and so on. Another disadvantage, which I don't mention but is important, is that some analyses simply cannot be retested using this approach, such as time series approaches and others that may look at curvilinear effects, maybe log linear as well, that don't transform to the univariate or normal distribution assumptions. A second method that can be used for testing reproducibility is recalculating the significance values. And what this allows us to do is assess the equivalence or congruence of the reported and recalculated p-value statistics. Allows us to evaluate the level and consistency of the statistical results associated with null hypothesis tests. Backer and Wichart's report that in doing this, they found about 20% of significance values of articles appearing in major psychology journals actually had differences, which they concluded were due to human error. So you can see this particular approach has yielded some interesting results in previous research. We can use several different analytical packages for conducting this p-value recalculation. Package of StatCheck, the software package R, or how I prefer to do it the simple way, Excel, an Excel spreadsheet. What do you need for this? You take a beta value out of a table. You take the standard error for that beta value. Again, this is all for a single variable. The t statistic, the degrees of freedom, and the reported significance values. In addition to t, you can also use a z variable or a z statistic, chi-square, f ratio, and even a Pearson's R. So a variety of statistics can be examined using this p-value. You can use this for any variable, incidentally, interaction terms, squared terms, and so on. You then, using an Excel statement, for example, you can then paste a formula to your Excel statement and recalculate significance values and then compare. What you can find is just go to Google and go quick p-value calculators, find the formula, paste in the Excel statement, and you'll immediately have p-values for those particular variables, allowing you to compare the reported significance value with the recalculated p-value and immediately seeing where there's discrepancies. This approach has several advantages. It's direct, very straightforward, allows apples-to-apples comparisons of reported significance as well as recalculated significance. It can be applied to large samples through using the software package such as R that just reads in articles and calculates them as it goes along. Disadvantages with this, it requires a complete disclosure of essential statistics, especially standard errors, degrees of freedom. So if you don't have those, you're unable to conduct this. It also does not pertain to the coefficient magnitudes or the directions. So those are two tests that we can use that are relatively quick and easy and give us important information. Again, we can also simulate findings as well, but I'll leave that for another presenter to provide the important information necessary to understand this. Moving to applications, there are two different settings I'd like to show and demonstrate how these approaches work. One is an article that was recently retracted in the Strategic Management Journal. And in essence, what I'm going to be looking at this particular article is, could the problematic findings be identified using the reproducibility test before that article was accepted for publication? I'm also going to talk briefly about a study of reproducibility of published data, and we're going to be looking there at how reproducible were the reported findings that we looked at. This first study was by Lichtenthaler and Ernst. I'll refer to them as L and E. In 2012, this SMJ article appeared, and it was subsequently retracted for material errors, according to the authors. They retracted it due to what they called technical errors, which they rendered many of the article's conclusions were incorrect. In the statement that this appears is indicated there at the SMJ in 2012-1341. So what I'm going to do is take you through this retracted article and see if we could find these material technical errors before the article was accepted, again using our two reproducibility tests. Just briefly, I apologize for how small this print is, but I want to give you just an overview of this article. They examined whether a firm's product development processes and technology licensing processes were complements rather than substitutes in knowledge exploitation. They offer three hypotheses and interactions among these variables. Their data was quite impressive. Multiple sources of data, multi-methods. They had interviews, as you can see, as well as surveys. And interestingly, they acknowledged, too, that their data had been part of an earlier study that had appeared in a top journal. Although, of course, this one was different because it was looking at different variables. And they indicated in their study that they had valid and reliable results. And I think as a reviewer looking at this, I might be very tempted to say, well, this study has passed its muster before. It must be a pretty good study. So as we look at this, it's be pretty easy to think the methods are in good shape. So if we take our tests, we get some different results. With respect to the matrix method, unfortunately, L&E didn't disclose the interaction terms in their correlation matrix. So we're not able to test the interaction models, but we can test the base models. And those models that do not include the product terms. And even when we test those models, we find numerous discrepancies between what they reported in the article and what we found in the reproduction. Most of the base models could be reproduced in none of the base models could be reproduced in their entirety. In most cases, the coefficients reported as statistically significant were not reproduced as such. In fact, they were non-significant using the matrix approach. So again, taking the correlations that they reported in the article, the means and standard deviations for the variables pertaining to those correlations, using that as input, rerunning the base models, we were unable to reproduce most of their reported statistics. When we recalculate their significance values, we found that all of them were larger or less significant than the original reported p-values. 28 of the 29 analytical models contained at least one problematic result, and up to 40% of the variables in a given model had reported significance levels that were different from recalculated models. In total, 77 p-values, 21% were discrepant. So we had some big red flags with those results. So we also looked at these using a simulation. I referred to this earlier, that there's going to be more discussion of this in another presentation, but I wanted just to touch upon this. We used Goldfarb and King simulation approach, and based upon that language, that program, we had problems replicating these results as well, using a Monte Carlo simulation with 1,000 unique draws. We found that the reported significance levels in this Lichtenthaler and Ernst article fell well outside the expectation. So the key takeaway from this is, had any one of these three reproducibility tests been used, there would have been red flags raised about Lichtenthal and Ernst's article, and certainly there could have been a dialogue with the author as to why these differences existed. So in each case, the reproducibility test came up with different findings than those reported in the article itself. Another question that arises is how reproducible are reported data and findings for studies at large. A 2017 article that we recently published, Herman Aguinis, Bart Sharp, and Lily Ming Lee, that appeared in Strategic Organization, attempted to reproduce empirical findings of a sample of 88 articles appearing in the Strategic Management Journal. Of those, about 70% did not provide enough information, enough data to permit independent tests. In other words, they may not have reported correlation matrices, or they may not have reported means, or there was some other reporting difficulty. And then as you can see, 70% of those, as I indicate here, could not be subjected to reproduction. Of the 30% that could be, about 2/3 of them we were able to reproduce. However, 1/3 reported hypotheses as statistically significant, which were no longer so. It was concentrated in just a few articles, fortunately. But far more significant results were found to be non-significant in the reproduction than in the opposite direction. And that raises some rather interesting questions. As we think about this second application, what we conclude is most SMJ articles could not be reproduced because they didn't report enough data. Of those that could be reproduced, we were able to get about 2/3 of them to come out just fine. About 1/3 of them had problems with their hypotheses. We're unable to reproduce those. And unfortunately, what we found in digging into those is that more of those previously significant results became non-significant than non-significant results reported in the focal article becoming significant. So that's somewhat consistent with what Goldfarb and King found, where they report 25 to 40% of coefficients seem to be outside of what the expected range would be. So for us, it's about 1/3. Moving on, we believe this reproduction tests have implications for replications. And let me explain to you why we think this matters. First of all, if you're conducting a replication, you get different conclusions than the focal article. You might conclude that the differences in your findings from the focal article are due to the differences in the two articles. That seems natural to do. For example, an article in a 2016 special issue on replication attempted to replicate 3 articles on signaling theory. They found no support for original articles, and they concluded that the reasons for the differences were due to sampling periods, measures, geographical context, extraneous factors, omitted variables, and so on. A very likely conclusion, very understandable conclusion. However, the differences between the replication article and the focal article could be due to other factors than just differences in the studies. There may be unknowable and undisclosed data decisions, errors, or even malfeasance in the original article that could cause or at least be the source of those differences. The reproducibility of that focal study would provide us information to help us better understand the differences in a replication. For example, if reproducibility is unsuccessful or not even possible, the ability to draw conclusions from a replication study could be compromised, as any difference between the findings of the original study and a replication could simply be due to those unobservable issues. For example, the original study may not have included the disclosure about outliers, or the results may have been cherry-picked, or the analyses may have been tweaked, and the analyses may have been altered in some way that produced findings that may not be clear given how the study was written. All of these are unknowable, and as a result, the ability to come to a correct conclusion about the reason for the differences in a replication, it could be difficult, and researchers face a true conundrum with these, as I'll mention as we move along. So the source of this error, differences between the replication and the reproducible study, could be due to simply issues in that focal study. So again, if the reproduction yields findings that differ from those reported in the original studies, Replication researchers are faced with a conundrum of trying to decipher the sources of those differences. Are they really the context, or are they something about the original study or its findings that weren't simply reported? If replication studies do not reproduce these focal studies, we're unable to replicate, if we're unable to reproduce the findings and we're unable to replicate them, we don't really know why those differences exist. So if we step back and consider reproducibility of the focal article and its replicability with respect to one another, we may get more insights into how these come together. So let's examine the relationships here between reproducibility and replicability. If we test an article's reproducibility, we have two possible outcomes. Yes, we were successful, or we weren't. If we look at replication, we were either successful or we weren't. If we put these together, it gives us four possible scenarios. Now this isn't readable, unfortunately, and I apologize for that. So I'm going to go through each cell independently in the following slides. But I just want to show you that if we go across the horizontal, we have replications. Say unsuccessful, successful. If we go on the vertical, we have reproducibility tests. So unsuccessful or successful. And considering the combinations of these gives us four different ways to interpret what replication may actually mean. Cell 1 in that matrix, where reproduction test, the original article, and the replication study findings are both unsuccessful. So in this case, we are unable to reproduce the focal article, and when we replicated it, we got different findings. What does that mean? Now, in many cases, the author of the replication may simply say the initial study wasn't replicable, and the differences in results are due to the replication differences. However, we may not know why those differences exist, and trying to make that conclusion is really vulnerable to error. And perhaps at best, what we really have, what we can say most confidently, is we have two related studies, and we don't really know why their differences and findings exist. Cell 2, the reproduction test of the original article was unsuccessful, so we were unable to reproduce it, and the replication study findings actually were successful, meaning that the replication corroborated or came up with the same findings as the original article, despite that we couldn't reproduce it, perhaps due to limited information on its reporting or its missing variables in the matrices and so on. What this would tell us is a confirmation of the original study's model. It would allow conclusions about those findings. We wouldn't be able to make strong conclusions about the original study since we weren't able to reproduce it, but we could at least say there's a strong observed effect across the two studies, and that may be, in fact, was driving the findings, not methodological variation. But at least we get confirmation that an effect exists. In cell 3, we are able to reproduce the original article, but the replication was unsuccessful. This is an interesting result for us because we know the original study findings are robust, and the fact the replication was unsuccessful suggests there's limits to the external validity of the original study, an important finding. From this point, what we may then do is look to reduce variation in the replication study with respect to its methodology, perhaps its measures, its analyses, even its sample, to see if we can locate a point where the findings of the replication and the reproduced study become equal. That would be important information for us to know. Finally, cell 4 tests. The reproduction tests were successful, and the replication study findings were also successful. This would tell us that the validity of the external validity or the generalizability of the original study is confirmed. So as we look at this, the variation in the replication study was corroborated and identified. And then what we may seek to do is add additional variation to find out if and when the results actually differ. So the point from all of this is what we see is that by jointly considering replication and reproducibility, it gives us new insights into how to interpret both articles' findings that we don't get when we just consider them independently. Reproduction of a focal study really gives us a baseline for interpreting the replication study's findings. That might serve as decision criteria for whether to conduct a replication incidentally. Let's say you're interested in replicating a study of interest to you. You want to pursue this study. what you may want to do is go and first see if you can reproduce that study using its reported data before you go too far along. If you're unable to reproduce that study, then you lose your baseline for comparing the results of your replication. Finally, this helps us understand why there may be explanatory differences. If we're able to reproduce and we're unable to replicate, that's important information. Maybe we can reduce the variation in our replication to see if we can get identical results, or if indeed the replication is successful, then we may want to add more variation to see when the differences would exist. So what we see with this is that reproducibility serves as a precursor or a precondition to replication. Recommendations. What we see in the literature these days with editors and reviewers and others is more calls for transparency and confirmation of findings. What we're looking at today with this material that I've discussed is to add reproducibility tests to this mix. Reproducibility serves as a monitoring mechanism, enabling us to see whether the information asymmetry between authors and readers, whether that can be reduced and diminished, because now we know whether an article's findings are reported fully. And again, it serves as a precursor, a precondition, and a first step to conducting replication. Our current understanding of replication, for example, and I apologize for how small this draws from the recommendations in the Strategic Management Journal about conducting replication, is to go and as closely possible match a replication study's design to the original study in order to help calibrate it. You can see the editor Bettis and his fellow co-editors suggested the calibration in terms of making the two studies as similar as possible. In addition to that, SMJ has provided reviewer guidelines for how to assess replication research, where they tell us to try to understand how the models compare and examine the quality of the data, examining the analyses as well and measures. And as we look at this is very sensible, reasonable, and logical recommendations. But this process would be strengthened by including these verification tests or reproducibility as a preliminary stage. I won't go through all of these fine print ratings here, but basically what this states is going back to reproducibility gives us information on that focal article before we go through a replication process. Because if we're not able to reproduce it, again, our conclusions, particularly if the replication is different, the conclusions can become subject to error. Our peer review, it's interesting to note that some journals have made no policy changes in response to an increase in retractions, survey results indicating that the authors have committed cardinal sins of data reporting, data fabrication in some cases. We've had other articles that have identified coefficient problems. I mentioned back in Wichard's 20%. We know that major seminal articles have been difficult, if not impossible, to replicate. We have evidence such as Goldfarb and King that report that 25 to 40% of coefficients in their sample of 300 SMJ articles fell outside the normal limits of where they should have been. So this is an important problem, and some journals have made no policy changes to respond to this. Some journals now require expanded disclosure of data, analyses, and findings, such as no longer reporting p-values using stars, requiring standard errors, etc. Some journals now include an expert review of the methods, the tests, as well as the findings. So as an article is working its way through the review process and it's nearing acceptance, a methods reviewer will be charged with going through the methodology to make sure it's reported fairly, clearly, and completely. A few journals may require a study's data through the aspect of output during the review stage. So Manuscript Central may include an upload of an output for reviewers to examine. Now, all of this is interesting to note because these are recognizing how journals and editors are responding to these. We would also add to this that reproducibility can be part of this process too, because it can help us confirm and verify findings. As I start wrapping up, information asymmetry, it's a condition that exists throughout life. All the major decisions, it seems, that we make are faced with information asymmetry. And I want to mention to you, I believe it exists in the publication process too, that authors know more about their data, more about their study, more about their analyses than their reviewers, the readers, and so on that do. Reproducibility may help address this condition by allowing us to identify possible reporting mistakes. It can also discourage some forms of questionable research practices, as well as scientific misconduct. And overall, this will help strengthen the field's empirical literatures and contribute to replication, as well as meta-analytical research through improving clarity. The slide I begin with asks you this question. How would you know if a study's reported findings are accurate and replicable without actually conducting an exact and full-scale replication? What I hope you've learned today is you can conduct a test of its reproducibility. Thank you.